Hey, Jason.
Hey.
Thanks for joining us. We kind of felt like watching your last talk. We were waiting for you to try to sell us a Mac or something, with your setup there. You missed an opportunity for, one more thing. But yeah, so let's talk about some chaos, right?
Yeah.
Sound good?
Yeah, I think so.
So, with regards to chaos engineering, a question, that I think comes up is like, why would you break things on purpose? Why, aren't we trying to avoid system failure? So like, yes, you're breaking it on purpose, but it's still broken, right?
Yeah, absolutely. So that's a question that I get a lot, right? I talk to customers, I talk to prospects, and everybody's just like, why should I break things? They just break on their own. And my number one response is that when things break on their own, they break on their own timing and they break on their own schedule. And if you've ever been on call, like, would you rather like have something break in the middle of the day when you've got colleagues around and you can fix it? Or would you rather have them break at 3 a.m. in the morning and wake you up, right? So it's pretty obvious that like, if we can control how we break things and we can learn from them and resolve them, then hopefully they don't happen in the middle of the night when we're off trying to sleep or celebrate, a party or something like that.
Or, be relieved that the DevOpsDays Chicago is finally over and we can all get a drink.
Exactly.
But so
I guess that's the other thing is like when they break on their own, you might be out drinking, and I don't know how many other people have done this, but like I've had times where I've been drunk and then needed to like fix something. Like, I should not be doing this.
I have definitely done that. I don't drink anymore, by the way, but I have definitely experienced that, and that was, like I said, not a good experience for anybody. So it kind of, based on what you said, comes back to the experience of getting good at this, right? Practicing the process, kind of like a football team, right? Practicing a process 100 times so that when the real stuff hits the fan, you know what to do.
Absolutely. Yeah, everything that we do takes practice, right? You're building up those skills, and then along the way, you're refining them as well, right? So it's not just enough to say that like, we did a fire drill and we practiced our on-call. Like, that's great, but like, I'm sure every time you run it, something happens. You realize like, oh, my run book is out of date, or it's not quite as informative as it needs to be. Here's the things that it assumed that I knew, or that it is, the state of the world that it assumed. And like, now there's a new service that's in play or other things like that.
So kind of one of the things that comes to mind is, if you're only testing the things that you've thoughtfully planned, does that limit your discovery to only those things you could think of to try, so to speak, right?
Yeah, and I think that comes back to, in my talk, that whole idea of unmet expectations is, as much as you try to plan for things, you inevitably find things that just don't match reality, right? So one of the common things that I love doing for chaos engineering is you think your application works in a certain way, right? So you have services and you're like, cool, I know that I'm dependent on my data store, but there's this other service and it's only like, it's non-critical, it provides some extra functionality. If that dies, I should still be able to operate. And so you go and you just isolate that from the network and everything falls over, right? So you plan for certain things, and really it comes down to validating what you think you know and whether that's true. And oftentimes what we think we know isn't correct, or not in the way that we think it works, right? And so there's sort of this misconception that chaos engineering is figuring out how things break. And I think that's sort of the glass half empty approach. The glass half full approach is, how does this actually work, right? Like, how does your car work? Well, we know it runs on tires, so you can't take out a tire, but like, if you start ripping things out from under the hood, will it actually work? What's necessary? What's just part of the air conditioning? Like, you don't know that. And oftentimes as engineers, we don't know that about our systems. We see a diagram, we can kind of draw some lines and think, okay, this is dependent on this, and we can see where things might break and where there might be points of failure. But ultimately, unless we try them out, it's all conjecture.
Well, and isn't that sort of the thing, right? You have a hypothesis, but your hypothesis is that this will not break, right? Like that if we make this change, like from our understanding of the system, if I shut off this interface or throttle this, my hypothesis is that things will continue to work. And I always like to think that if your hypothesis is not that, then you should not run that experiment, right? If your hypothesis is everything will go terrible and I will lose $1 million, you don't need to experiment. You need to go fix it because you already know that part, right?
Right. Well, so for the expectation of breaking things, right? Back when I worked for a small cloud company, right? We had an outage because a lightning bolt struck a data center, right? Like, okay, starting off like what? But also like, so my particular product, we thought it was distributed between data centers, except it had a part that wasn't distributed, that was in that particular data center, and that was the part that just got completely throttled, and we couldn't do anything else because that one piece wasn't working, so it didn't matter that the other parts were geo-distributed, right? And that's a learning experience you can't really predict, so the thing about that is that you don't want to do that to your customers, right? When we do red teaming, we never break things that will affect customers on purpose, right?
Well, but you're never, well, that's red teaming, but again, like I guess, and maybe this is oversimplified, but again, my point is to test the hypothesis that I've actually built a reliable system, right? You know, so in that case, you know, in the case of your just non-distributed system, as it turns out, you had a hypothesis that it was distributed, you know, so you weren't doing it, like, again, if assuming that the lightning storm was a chaos experiment, and by the way, that's impressive. So when is Gremlin coming out with like electrical storm on demand is what I want to know, right? But you would be testing, now you would find out that your hypothesis was incorrect, and you learned a thing, but if your hypothesis was if I knock out this data center, everything will go to shit, yeah, don't test that hypothesis. Like, get yourself to the point that your hypothesis is that your stuff is reliable, right?
But you also bring up that good point of like trying not to impact your customers, right? And so there are a number of times where you're testing and you do know that it's a little bit risky, right? Something could go wrong. And so everybody always thinks of chaos engineering as like, oh, I just do this in production, right? And like, yeah, like eventually you want to get there. But it's like, I mean, you don't just like write new code and deploy it straight to production. Like, so what makes you think that you should do the same with chaos engineering, right? Like start in a development environment, move into staging, move up to production, like get comfortable with this rather than just like YOLO ops.
So when we think about adopting the practices around this, like what do you see as kind of the percentage or the split or the focus of like your infrastructure eng versus your app dev or you know, like your SRE versus SWE kind of as taking on these chaos experiments as an ownership, if you will?
Yeah, so it's funny because I'd always like, because coming from like that DevOps like background, and most of us have like some ops experience. I mean, I've also got some dev experience, but you know, we usually think of like, well, if I'm doing these experiments, I'm doing things like, you know, blocking network traffic and like spiking CPU, that's like infra stuff. And so I always assumed like, oh, it's going to be like ops engineers and SRE folks that are like super into this. And the funny thing is, the more I talk to people, it's actually been more software developers and software engineers. And I don't know, like my hunch is that that's because as we've moved into a more DevOps world and we're breaking down silos and we have cross-functional teams and essentially software engineers are owning those services, they're more invested in that idea of what happens, like, yeah, my code's good, but like what happens if something else happens? Like, how does that affect my application? And I think they're also more sensitive as we've gone into a more service-oriented world of like, what happens when somebody else's service or some other like third-party service that I'm using, what happens when that goes down? So it's been an interesting thing to discover that more and more software engineers are looking into chaos engineering.
So this is actually interesting because we went into titles. And so I've been saying this for the past year plus, but I want a job title of the chaos monkey. Like I want to be paid to break things on purpose, to be that person.
But you want to be called the monkey, not a chaos engineer. You specifically want to, yeah, just so we're clear. Wouldn't you be a chaos cat butt?
only if I have 10,000
Only with
followers.
10,000 followers.
Yes, but so I would say it's an interesting problem to solve, right? To think of all, it's kind of like red teaming again, right? It's kind of like breaking things. How can I break this system in the most ingenious way? Like, how can I think of that lightning bolt, like simulate that experience? And I know that now there's companies who actually do this on purpose, but also like, there's definitely a part of this where it should be a human job because we are, we've got imagination on our side.
So I would say that it's sort of yes and no. Like, no, for like most people doing chaos engineering, you don't want to do that super creative stuff. You really want to think simply about your systems and like start with the basics of like, does my monitoring work, right? How do you know your monitoring works, right? I worked at Datadog. It could be complete like BS, just like random number generator. Like, you actually have to like play with your system and be like, this should spike CPU, and then look at your dashboards and does it actually do that? So the simple stuff is what you want to start with. Getting creative and like replicating incidents is definitely something that you can get to. But I feel like that's less about testing your systems as it is like having a safe place to replay that incident and react to it, and like test your processes and how are people gonna react and how did they learn from that past incident about like how they should act in an incident.
Well, I think it goes to the difference of reliability and resilience, right? So like what we're talking about with chaos engineering, with these experiments where we have the hypothesis, we're testing reliability and robustness to a certain point, right? Whereas the wacky, weird shit that the chaos monkey over here wants to do, that's resilience, because like you're not going to build technology, like you're a way to adapt to like Godzilla comes and kicks over the transformer is like your adaptive capacity. You don't you do that with the socio part of the socio-technical system. So it's like, I think the chaos is not about finding a way to break, it's proving your hypothesis of that you have built a reliable system.
So actually this kind of brought up a question in my mind, which is chaos engineering, like the way you see it at least, is it about systems or is it about people? Like, what are you trying to prove that the system is resilient, or are you trying to train people to be resilient in a case of failure or something?
Yeah, it's definitely about both, right? I mean, when you're starting out, it usually is about the system, because again, you're just trying to like verify that the thing you built works in the way that it's supposed to, or that you think it's supposed to. But as you do that, like running game days is a great chance to practice your incident command, right? And to start to build up those human processes as well. So it definitely is a both.
It's a safe place to basically create that sort of psychological, physiological association of incident response, right? So here's kind of a little chaotic, maybe, is why the hell do you organize so many conferences, Jason?
Why do I organize so many conferences? I get roped into things. I don't know, like, and I'm an idiot. Like, clearly, like that was my whole slide point, was like, I don't know why people listen to me. Like, I have this credibility on my slides, but like, I'm honestly just kind of an idiot. I just happen to do some things really well, and I like community. So maybe that's it, is I'm just like addicted to building communities because I love interacting with people. Or I could just blame Sasha and Ken for at least DeliveryConf.
At least one. It's so, it's funny how, like, I think it was in Brian's video, right? You join a happy hour once, and then you find yourself doing community work for 10 years.
Well, in Brian, it wasn't even a happy hour. He just got confused.
I mean, some of it too is like, y'all are great people. Like, the people that I've met through DevOps Days, whether it's at like DevOps Days events or just like other events, are some of the most incredible people that I've ever like hung out with and that I've had the honor of calling friends. So when you get to hang out with a bunch of people and spend a bunch of time with them and build communities and build spaces where people can hang out and like build new friendships, like that's super rewarding. So.
And I think personally to me, like I know how, DevOpsDays in particular had impact on my career, but also like I've had these moments over the years where people come up to me and they're like, oh my God, if it wasn't for this conference, I would never have X, right? And you have this like sentimental, like, I want to cry right now and hug you forever, like, because you realize that what you do actually matters and it's bigger than, pushing a line of code into production.
I think conference organizing is really about being a force multiplier, right? It's like we're bringing together all these resources and stuff and being able to sort of expand it and share it and do everything at a greater level than you would just by yourself. Sharing your thoughts on, how to chaos test which Pokemon team you should be on or whatever. What do you think is the likelihood that whiskey and chocolate will become a factor in a updated release of Pokemon Go? Like maybe as drops or anything?
Probably not that, but definitely a factor in my life.
Yeah.
So, yeah.
Am I supposed to say something?
I don't know.
Sorry.
Yeah,
I don't know. Did you receive the chocolate though? I'm assuming you did.
I did not
since you-
actually. So
So you should check your mail because it should
So
be
for the
arriving
hundreds of
any
people
day.
listening to the live stream right now, then we're going to take a minute to talk about some logistics of chocolate that Jason is shipping to Sasha. So don't mind us. Talk amongst yourselves. I'll give you a topic. Configure infrastructure as code is neither infrastructure nor code. Go discuss.
You're supposed to read.
Do you want to get a tracking number from him or something now? So I'm going to ask you one more serious question. So is it a goal, this is coming from the chat, is it a goal to automate a completed experiment as a future test, right? Like you're continually testing, like how does automated chaos engineering work or for that matter, not work? And does this alleviate some burden on the humans in the system?
Yeah, absolutely. So, we talked about before, is chaos engineering more for testing your technical systems or your human? And I said both. But obviously for the technical side, right, like you're an engineer. And so anytime you do something manually more than a few times, you should automate it, right? That's just standard engineering. And so it's the same with chaos engineering, right? If I have a hypothesis that if my service goes down, it should automatically restart and like be added back to the load balancing pool, like that's an easy thing to test for. And so you can start to just do that. Like as it rolls out, one of your CD pipelines is deploy it to this chaos environment, kill it, see if it comes back. And that's just a test, right? So you can start to do at least a lot of the basic stuff as automated tests.
Sorry, so you're going to add on to your unit tests, and now you have system failure tests? I don't know what to call them.
Well, you're not testing failure, you're testing the condition, right? Like you're not trying to make it fail, but you're saying like, you're able, again, if the thing you're testing is if the network connection is throttled.
Is there a name for this? Is there chaos test? Like what's
I feel like, a bunch of people have called it like chaos testing or reliability testing. There's no industry defined term, so you can just make up some silly name. Chaos engineering in itself is a silly name.
Please feel free to fight about made up words with us on Twitter. Tag GetBisect, Divine Ops, and Matt Stratton, and we're going to come up with a new name for a thing that probably already has 7 names. And I think that's the thought leadering we're going to leave with here. So, Jason, thank you for sharing your thoughts on the Pokemons and the whiskeys and the chocolates and also the chaos.